Pop quiz. You mix equal volumes of 0.10 molar acetic acid and 0.10 molar sodium hydroxide. After things settle, is the solution A, acidic, B, neutral, or C, basic? Lock in your choice. We will reveal the answer shortly. In this video, you will learn a repeatable plan for any acid-base question. First, list the major species and how they behave. Next, decide whether a reaction goes essentially to completion. Then, identify which equilibrium dominates. Finally, set up a simple table if you need numbers. Step 1. Inventory the solution. Do we have a strong acid or a strong base? Do we have a weak acid or a weak base? Or a salt whose ions might act as an acid or as a base in water? Knowing who is actually present tells you what can happen next. Step 2. See if something goes all the way. Strong acid HA dissociates completely to H plus and A minus. Strong base BOH dissociates completely to B plus and OH minus. When they react, the reaction goes to completion. Weak acid HA dissociates partially to H, 3O plus and A minus. Weak base B dissociates partially to BH plus and OH minus. With them, you will need an equilibrium calculation. Time to reveal the pop quiz answer. Strong base sodium hydroxide neutralizes acetic acid, that's a weak acid, leaving the conjugate base in water. The conjugate base produces OH minus ions that make the solution basic. So the correct choice is C, basic. Here is the overall play. If a strong acid or base is around, do a quick limiting reagent check first. If not, and you have a weak acid or a weak base, pick the single equilibrium that matters. If you have a salt, test both the cation and the anion to see which side controls the pH. Let's ground this with the weak acid template. A weak acid in water partially donates a proton. To find pH or concentrations, you set up a simple initial change equilibrium table with one unknown. Often, a small x approximation is enough to finish. Here are 3 quick fixes. First, not every mixture needs an equilibrium table. If a strong partner is present, neutralization comes first. Second, salts are not automatically neutral. Some ions act as acids or as bases in water. Third, for many polyprotic acids, the first step dominates, and the later steps are negligible at common concentrations. Here is a mini checkpoint. You can now list species, decide on completion, choose the main equilibrium, and reserve tables for the weak stuff. Want to check your progress? Tap the link for a quick practice test and a concise study guide tailored to this lesson. Quiz yourself, skim the highlights, and jump back in. Let's deepen the strategy with a salt example. Ammonium chloride dissociates to give the ammonium cation NH4+, and chloride anion Cl-. Chloride anion is the spectator ion here. The ammonium cation donates a proton to water and produces the hydronium ion. That means this solution is acidic. What if a salt contains an acidic cation and a basic anion at the same time, like ammonium acetate? To do this, compare their strengths. Use the acid dissociation constant Ka for the cation and the base dissociation constant Kb for the anion. The greater one wins, sets the equilibrium direction, and decides the pH. The acid dissociation constant for ammonium cation is larger than the base dissociation constant for acetate anion. The equilibrium of ammonium cation dominates, so the solution is net acidic. If you need a number, you set up one simple table for that winning equilibrium only. For polyprotic acids, the first proton donation is usually much more impactful than the second. In many classroom problems, that first step alone controls the pH. You bring in later steps only if the problem's numbers make them matter. Watch out for these traps. Strength and concentration are not the same thing. Always check for any leftover strong reagent after neutralization. And do not try to juggle several weak equilibria at the same time. Pick the one that dominates. Let's practice the moves you will repeat on tests. 1. List major species. 2. If a strong acid meets a strong base, do the completion step first. 3. Decide which single equilibrium controls what is left. 4. Set up a quick table only for that one. Recap. List what is in the beaker. Decide whether anything goes all the way, and then choose the single equilibrium that dominates. Use a simple table only when you need numbers. With this playbook, you can navigate almost any acid-base problem.
Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.